Good day and welcome to Math 111H Calculus 1 Honors, The Joys of X. On today's show we'll discuss some simple integrals and the method of substitution. So far we only know how to find the antiderivatives of a small set of functions. Some examples of those are that the integral of a constant k is kx plus a constant. The antiderivative of dx over x is the natural log of x plus a constant. The antiderivative of x to a power n is x to the n plus 1 over n plus 1 if n does not equal negative 1. The integral of e to the x is e to the x. We know how to integrate sine and cosine, 1 over 1 plus x squared, and a few other functions. But the list is pretty small. The method of substitution helps us to broaden the variety of functions we can integrate. For example, consider the integral of 2x times the square root of 1 plus x squared dx. This doesn't look like anything we've taken an antiderivative of so far. However, if we use the u substitution technique, we let the u equal some messy part of our expression. In this case, it becomes worthwhile to let u equal 1 plus x squared. Getting an idea of what we should use for our substitution comes with experience. So if we let u equal 1 plus x squared, then the differential du equals 2x dx. Now we can substitute u's in for x's. Okay, we note the expression 1 plus x squared is u, so we have a square root of u. And then we have a 2x dx, and we can recognize 2x dx is exactly du. So we've now substituted du for 2x dx, u to the 1/2 for the square root of 1 plus x squared, and we simply have the integral of u to the 1/2 du. We know how to find the antiderivative of u to the 1/2. That's u to the 3/2 divided by 3/2 plus a constant. We can simplify that. The 3/2 in the denominator becomes a 2/3. U is equal to 1 plus x squared, so we can substitute back in so that we get an answer in the same variable that we started with in terms of x. And we find that the antiderivative, or the integral of 2x times the square root of 1 plus x squared dx is 2/3 times 1 plus x squared quantity to the 3/2 plus a constant. One can always check one's work when performing integrals simply by differentiating. If you take the derivative of 2/3 times 1 plus x squared to the 3/2, we should get what we started with. Some comments. Evaluating integrals is different from taking derivatives. The ideas, the concepts are somewhat different. That doing integrals is more creative. It's kind of like solving puzzles. You have to recognize patterns, you learn from experience, and so it's a little different from taking derivatives. Taking derivatives, one can always go back to the definition of the derivative, and that's a more standard recipe kind of thing to do. We notice from the substitution technique that the dx became crucial. If we didn't substitute the du for the dx, well, it's easy to get confused and to make an error. So a lot of students will ask, why do we have to have a dx when we take an antiderivative? Not only is it useful to kind of keep in mind the delta x length in the area, but it comes in as crucial when performing substitution. Sometimes more than one substitution will work in a given problem. Sometimes many substitutions that you try will not work. And so it takes experience, and it might take a little experimentation to find a substitution that works in the case that you're interested in. And finally, if there are limits of integration, you must get back to the original variable in order to plug in those limits, or you need to adjust the limits to deal with the new variable. If you start with x, you turn it into u, you either have to change the limits to make them limits in u, or adjust or go back to x in your solution, and then you can plug in the limits in terms of x. Mrs. Johnson, the elementary school math teacher, was having children do problems on the blackboard one day. Who would like to do the first problem, addition, she asked. No one raised their hand, so she called on Tommy, and with some help, he finally got it right. Who would like to do the second problem, subtraction? Students hid their faces. She called on Mark, who got the problem, but there was some suspicion that his girlfriend Lisa whispered the answer to him. Who would like to do the third problem, division? Now a low collective groan could be heard as everyone looked at nothing in particular. The teacher called on Susie, who got it right. Who would like to do the last problem, multiplication? Timmy's hand shot up, surprising everyone in the room. Mrs. Johnson finally gained her composure. In the stunned silence, why all the enthusiasm, Timmy? She asked. Well, God said, go forth and multiply. Thank you for joining us today. Have a great day, and may the power of math be with you.